automated response is that, oh, I would never do that, right? I want to be in control of my system. I want to, be able to decide what happens and what type of response I take, and I don't trust a machine to do that for me. And I think those are some fair assessments. So what we wanted to do is give you a talk today about different ways that you can apply automation. And there's lots of different forms of automation, and we're going to go through those. So my name is Chris Blauvelt. I'm an electrical engineer by training. I spent 10 years in power generation before coming to Fortinet, where I've been for 3 years now. Carlos Sanchez spent how many years in oil and gas? 15 years in oil and gas before coming to Fortinet. He's been with Fortinet for more than a couple years. And Nathan Dan has been in process automation, automation networking for several years. So we're going to talk to you today about how we can apply different types of automation and what that means. And so what we're going to be doing is talking about the engineering processes that give you reliable automation, give you reliable situational awareness, and some of the things that you can do to increase the amount of response time that you have. Essentially moving from the I'm under an attack and things are shutting down within my plant to, hey, something's not right here, let's investigate. And so we have two scenarios. Like I said, I come from power generation, so I spent some time doing reliability engineering. And so, here are two situations where we need intervention, right? One is a fault occurring on an electrical line requiring a breaker trip. When you interconnect with a large transmission owner, you are told if you have a fault within your system, you have 125 milliseconds to trip, right? And you have to backwards plan that. And what you usually end up with is you have 1 or 2 cycles, which in North America is 1632 milliseconds, to be able to trip, right? Including breaker operation. That is obviously well beyond the ability of a human to make a decision, right? So we have engineered systems for that, okay? Now, another scenario that we have, sometimes as a result of scenario 1, is we have a transmission line that ends up carrying 110% of capacity. Maybe some generation dropped out. This is an acceptable situation. We've planned for this, and we know that we can run in this situation for at least 30 minutes. After 30 minutes, we're going to start causing damage to the line. You're going to get droop in the conductors. You're going to damage those conductors. And so when we are planning for reliability in the electrical grid, we have different contingencies. We had the N-1, which means one thing goes wrong, right? Maybe you have a line to ground fault and you have to take out part of your system, right? Why are you taking out part of your system? Resiliency, right? You want the rest of the system to be able to survive so you can continue to provide electrical service to your customers. There's the N-2, which is a double failure. Maybe you have one pole with 2 electrical lines on it. Maybe something happens that causes 2 current carrying paths to fail. And then we have the N-1, which does not equal N-2, all right? Don't try to do math here. What this means is I have a failure, I respond to the failure, and then I have another failure in an unrelated system, right? So that's generally the degree of planning that we go to in a transmission electrical grid to be able to understand the impacts of failure. And so what are those N-1 or N-1 contingencies? We look at every device, every single device within the electrical grid. And we say, what would happen if that failed? Okay. This is the kind of engineering that you can do, right? Now, electrical grid, cost is not usually a factor. In most other industries, cost is always a factor, right? So there's different trade-offs that we have here. So you might decide that a certain system failing and the subsequent amount of your capacity that comes offline is acceptable, right? You might decide that your HMI that's running Windows XP has malware on it, and you're going to take considerations to allow that to continue to run with malware on it for the next 6 months because that's when your next scheduled shutdown is, right? These are corollaries that we can draw to things like manufacturing or other industries that we have. And so what are some of the fundamentals of automated response? When we talk about reliability and systems operating automatically, what do we mean? In power, we talk about dependability, which means it operates correctly when it's supposed to operate. We talk about security, which I understand is confusing in this context. But security, what that means here, is it does not operate when it's not supposed to, right? It sounds obvious, but again, we're talking about fundamentals here. Then we talk about specificity. I don't take down the entire state of Florida because I had a fault on one line, right? That happened in 2003, and we didn't like it. So we designed around it, right? So what does that look like from a cybersecurity context? I have a malicious process running on an endpoint. Do I shut down the whole endpoint? Can I maybe just shut down that process, right? And continue to operate? What are my risk calculations? And that's going to be different for everybody. And so what are some of the levels of automation? I think, maybe not in this room because we're all at a security conference, but a lot of our customers are coming to us at level 0, right? They have no information, no automation. That's your typical flat network. You're not seeing what's going on, and you wouldn't be able to do something about it if you did get attacked. And so then we move on to passive monitoring, which is the alarms, right? We're getting information. We have to manually process, manually triage these alarms to determine if there's an issue. Then we get into monitoring, alarms, and recommendations. This thing has happened. I recommend that you do X, Y, Z, right? What does that look like in the security context? That might be a playbook that you already have set up in some type of system where you can, something happens, you open the playbook and you execute the steps, right? Maybe you don't have an automated platform, but you have an SOP, right? You have a checklist. By the way, big fan of checklists. If you're not generating checklists, when in the heat of the moment, you will definitely wish you had them, okay? There are automated platforms, we call them SOAR in cybersecurity. That is essentially a way to automate that checklist. You can do the next step, click next, next, next. Okay. So the next thing is the person in the middle automated response. We do this in the military. Before I was in power generation, I was in artillery, and we would monitor for incoming fire. And then we would shoot back, right? We have the capability to automatically shoot back at whatever's shooting at us. But we don't. Why? Because it's a policy in the US Department of Defense that there will always be a person in the middle deciding when to launch kinetic weapons. Okay? So, what does this look like from a cybersecurity perspective? I have an event. I have maybe fully automatically taken some action. I have stopped an endpoint or stopped a process on an endpoint. Now I am recommending that you take a look at these 5 endpoints because my data tells me that there's indicators of compromise based on this malware that I have seen. And then you have the fully automated response. I have not seen anybody do this. We were talking to a vendor, an OEM, and came up with an example of what fully automated would look like. I have a DCS system that has 2 HA controllers. My primary gets compromised. I recognize that, kick over to my secondary, and quarantine the primary. and I prevent that secondary from talking to anything that's not a part of its DCS system, right? That's just an example of where some of the OEMs are looking to move to. So how do we use automation to improve situational awareness? We know people are not good at passively monitoring information for a long period of time. That's what you get with alarm fatigue, right? Maybe it's a false alarm that you're always getting, and when it does come in and it's actually right, you don't know or you don't care, right? As we start to increase the complexity of these systems, the aim is always to decrease the complexity for the operator. Sometimes that means decreasing or increasing the complexity for the maintainer. It's a lot harder to drive a Model T than a Tesla. It's a lot harder to fix a Tesla than a Model T, right? And so what are some factors in operator responsiveness, right? We're talking about trying to give you more response time, but how do we improve your ability to respond? And so when we look at the data that we have, right? If we have high fidelity, low fidelity data, we have high confidence and low confidence. What are some things that would cause low confidence? A commonly failed alarm, right? Or a false alarm. What are some examples of people operating with bad data, but they have high confidence in it? If you read the after-action reviews of the 3 Mile Island disaster, that's exactly what that was. Is they had bad data, but they had high confidence in that data. Now, here's something to remember that in an industrial process you don't always have, right? The designers are continuously trying to give you better confidence. In a cyber attack, your adversary is always trying to reduce the level of fidelity and give you high confidence in it, right? And so these are the different columns. If you look at the MITRE attack for ICS, these are the different actions that you go from initial access to impact, right? And as you move to the right, you're going to have less response time, less fidelity, right? A breaker operating is a very violent response to an issue, right? You might have similar violent responses in your safety systems, right? So the idea is that we want to move ourselves back to the left, catch things earlier, catch things that give us more ability to respond in a control-managed manner, right? And so this is partially defense in depth. When I talk about N-1-1, that's your antivirus doesn't catch something coming in, but your EDR does. That is, your physical security guy clicking yes, log in, but then something else on the network is able to detect malicious behavior, right? That's your N-1-1. We call it defense in depth, okay? And so what we're going to look at is different ways that we can move things to the left, improve our situational awareness, and give ourselves the ability to respond in a timely manner to cyber attacks.